Hello, this is exercise 17D.1 because we actually come back to this again in year 13. As I've already explained, we do a bit of the normal distribution, which is thought of as a year 13 topic, but we do it in early in year 12 just to make a head start on it. But this is one part that we'll come back to next year. So let's, before we get started, then just have a little starter of what we saw last lesson. And last lesson we were looking at how to use this Casio Classwiz calculator to work out backward questions. So this is one of those. So it says the mean height of a type of yucca plant. This is obviously a yucca plant. It says is well, let's assume not, yeah, because it does say normally distributed here. So x is normally distributed, and it says and the mean is 40 and the variance is 8. Now ignore the fact that it says 8 centimeters squared. That basically means 8 for sigma squared is 8, and therefore sigma is simply root 8. We're going to have to bear that in mind. And we want to sell these plants at prices determined by their height. The shortest 30% will be, oh, dodgy line there, that will be sold for £20. So so as my mean is at 40, and it says the shortest 30%, so I'm going to pretend that's there, and this 30%, which I'm presently colouring in there, this is 30% worth, and it wants me to work out x, I think. Assume that these are normally distributed, find the maximum height for the yucca plant sold at £20. So yes, so this is the x. It's a backward question. So we've seen before we do inverse normal in this, and we get that by pressing menu 7.3. So I'm going to do it on my calculator now. Menu 7.3, inverse normal, and the area is obviously going to be 0.3 because it says it's 30%, and of course it's always lower than values, which is what it is. And then it wants sigma. And sigma is root 8. We've talked about that before. That we've just got to be a bit careful with the root 8. It could be easier to type in 8 there. And mu is 40. So I've typed all those into my calculator. I just now need to press equals, and it tells me that that x value is 38.5 centimeters. It's 38.52, I think, but to 1 dp, that sounds right. Let's see what I've got here. The answer 38.5 centimeters. So it doesn't seem to be much difference between them. 38.5 is, you probably wouldn't even notice that. Anyway, so that's that started there, and then just remind us of what we've seen before. And today is different because today we're going to try to use mu, or find mu and sigma. And whenever we're trying to find these are the tricky ones. There's no doubt about it. These are trickier than anything we've seen so far. So, and there's no way around the fact we've got to use this z equals x minus mu over sigma formula when I do it. So whenever you're finding these, expect to use this, and also expect to use the calculator as well. You have to use the two of them together. So here's a couple of quick examples. It says, if x is normal, notice we don't know what mu is, it just says mu, but we know what the variance is, it's 9. So let's just draw a little picture. I'm not sure if it helps, but we'll do it. We don't know what the middle is, but we know that sigma is 3, because it's obviously 3 squared. It said the probability x is greater than some number 18 is, well, actually it's quite large, on 0.65. Because it's more than half, I know that 18 is over here. So whatever this mu value is, it's more than that, because I know that this percentage is 65%, and well, by definition this is 35%. Now because I want to find a mu value or a sigma value, very first thing is I use my calculator to get me z. So I'm going to find z, and to find z I'm going to set the area equal to 0.35, a lower than value, but I have to set sigma equal to 1 and mu equals 0. So I'll do that now. Let's go for it. Still inverse normal. Area is 0.35. 0.35. Type it properly always helps. Sigma is 1, mu is 0, and it tells me my z value. Z equals, it actually says x inverse in the calculator, but I ignore that. It's minus 0.385. So now I've got that value for my calculator, I can now find well, mu. And of course I use this z equals x minus mu over sigma formula. My z is minus 0.385. My x is what I'm, well, I know my x actually. My x value here is 18. My mu actually is what I'm after. Trying to get that. And what was my sigma? My sigma in actual fact was 3. So you can see effectively I can move that over. So you kind of got to go to menu 1 here. You've got to get out of that calculator mode. Minus 0.385. I'm going to times by 3. There's a chance of a little error there if I'm not careful, I suppose. But I've got minus 1.155 is 18 minus mu. And my gut feeling is I'm going to move those around. It become a plus. So 18 minus that number. And I get obviously 19.155 or 19.2 I suppose to 1 dp. The second question, very similar. This time at least I know what that is. It's 8. And the probability that x is less than 7, it says, is 42%. So that's, I get told this is 0.42. Less than 7 is on the left hand side. So that was right. So my first job again, because this time I obviously want to find what sigma is, what sigma squared is. So to find z first of all is what I do. Area equals 0.42. And again, notice I'm going to go sigma equals 1, mu equals 0. Whenever I want to find my z, that's what I do. So menu 7, 3 again, 0.42, 10. And I get, again, it's on the left hand side, so it's no surprise, z equals a negative number, minus 0.2019. I'll give myself an extra decimal place, trying to be a bit more accurate, I suppose. The more accuracy you leave here, the better. And I suppose I can just jump straight to the fact this is equal to x minus mu over sigma. Let's put some numbers in there, minus 0.2019 equals my x was 7. My mu was 8, is my sigma this time I'm after. And these two switch places, and effectively it gives me sigma equals 7 minus 8 over that minus 0.2019. So I'll do that now. Menu 1, 7 minus 8 divided by negative 0.2019. And I get 4.95 for my sigma. Now you've got to square this. This is where errors can creep in. So I'm just going to press squared and hope I'm accurate enough. I get sigma squared equals 24.5. It wouldn't surprise me at all if it was 24.6, for instance, or 24.4. 19.2 to 36 figs, 24.5. That's all right. Actually, I've got exactly the same answer as I had in my calculator, so I've obviously done it relatively accurately. So far so good. So that was 2 quick examples of how to find a sigma or a mu from a probability given to you at the start of the question. Notice the 2 approaches. You find z, and then you find the other thing using your formula. So there were times when you get 2 pieces of information. So let's go through these 2 and I'll show you what's going on. The first question, I'm ready, I'll already draw in a picture. It says, look, this you can tell the difference already. I don't know either. Mu is gone, sigma squared is gone, I don't know anything. But what I do know is x is less than 3 is a relatively small number, that's 0.2. So I'm going to write 3 there. Obviously my mu is down the middle. But this says 0.2, so I'm going to say 20%. And bigger than 12, so 12's over here somewhere, is 10%. So that's 10%. So I need to do what I've done before, but for both ends. So I need a z for both ends. So for z, let's find z first of all. I'll do that end. I'll do area equals 0.2. Notice sigma equals 1, mu equals 0, and my z is equal to, let's just do it, menu 7.3. So what was it? It was 0.2. And I get minus 0.84 when I do that. In fact, minus 0.8416. And at the other end, I've got an area equal, I'm going to use 0.9 here. Now remember, you always have to do to the left of it. So that's why I've done that. Sigma equals 1, mu equals 0. Exactly the same technique. 0.9 this time. I get 1.28. So Z equals 1.2816. Now look, for both of these now I have to find, I have to use my equation. So I write Z equals x minus mu over sigma. Now for the first one, that gives me minus 0.8416 equals x was 3 minus mu over sigma. And notice all I do is I move that over there. Minus 0.8416 sigma equals 3 minus mu. And if you're any sense about it, you'll move the mu over there and you'll get mu minus the 0.8416 sigma equals 3. I say that because you want to set it into a standard way for simultaneous equations. This ultimately comes down to simultaneous equations. The second one, I do the same trick. It's Z equals x minus mu over sigma. And therefore I get 1.2816 my Z equals x. What was x? It was 12 minus mu over sigma. And again, move the sigma over. And at the same time move the mu over, and I'll end up with mu plus this time 1.2816 sigma equals 12. And this is my second equation. Now this, I pretend my mu is like an x, and I pretend my sigma is like a y, and I press menu on my calculator and I go down to A, and I'm able to solve simultaneous equations. So using my simultaneous equation solver, I now press menu A and then 1 for simultaneous equations. There are 2 unknowns, and it says how many x, how many y, what's the number. So this is obviously mu equals 1. I've got one of them, so I'm going to type in 1 mu, or 1x, and I've got 1.2816 sigma, and that equals 12. That's my first equation typed in, and now I'm going to type in this equation, and again I've got 1 of the mu or the x. I've got negative 0.8416 y, and that equals 3. And this just tells me what the answers are. My x, it says, now notice my x is reading mu, and I've got a horrible fraction, but when I press the button it says 6.57 to 3 significant figures, and my sigma equals, and this is what it says is y, but I know sigma is well, it says 4.2, well, again I've got to be a little bit careful, it's 23888, so there you go. I want to do that because it says sigma squared, and of course sigma squared is the variance, so I'm going to have to type that in, menu 1. This is when you wish you had 2 calculators. So, what is it, 4.23888, and I'm going to square that number. And I get 17.97. I don't know if it wants that, to basically, to 3 sig figs, it's 18.0. And we'll see if that's the answer they want. So let's have a look. Yeah, 17.97 to 3 sig figs, 6.57. Did I get that? Yes, I did. So both of those work. Now, we've got another one. I'm going to leave this one for in class, because I think these are hard enough to warrant doing these in class. And a reminder of how it is we're doing it. And then just a reminder for you, perhaps, a summary for the Casio Classwiz then. I suppose it highlights there are 4 types of questions that we have to be able to do. The nice, gentle ones. Number 1, if you like. It's find the probability. Use the number 2 button on a calculator, normal CD. Then we start the backward ones. The easy backward ones, when you want an x value, and we just press inverse normal, we type in the proper value for mu and sigma on both these type of equations, and it tells us the answer straight off. But sometimes we want to find the mean or the variance of the standard deviation, and we've seen today that we use the Z formula with this, and even the hard ones we use to find both of them. We end up using simultaneous equations. So that's what we're going to practice in class, exercise 17D. It's an exercise we'll come back to in year 13, but for now we'll try and just concentrate on questions 1 and 2. So thank you very much.